Hello everyone, I hope all are doing well. So in last video we have discussed about condensation, humidity, dew and fog. So today we are going to discuss about boiling. To understand about boiling we are going to do about activity 10. So let's do an activity about boiling. So boiling. To understand more about boiling, now we are going to take a vessel with water. So after taking the vessel with water, you have to take a thermometer to make a note of readings. Okay. So after that, you just keep them on burner. So after keeping them on burner, start supplying heat to that vessel. So when you supply heat to that vessel, what happens? First, suppose just you supply it first 20 degrees Celsius. What happens? The temperature of the water rises or fall? The temperature of the water will be raised. Okay, so next you are going to supply 40 degrees Celsius. So what happens to that water? Water temperature will be rising. Next you are going to supply 60 degrees Celsius. Next 80 degrees Celsius. Next 100 degrees Celsius. So the rise of temperature takes place continuously, or will it stop at anywhere? The rise of temperature taking place up to 100 degrees Celsius. After reaching 100 degrees Celsius, it will stop rising. Why? What happened? Let's see what happened. So what happens means, here we have taken water. So water is a solution. Yes, water is a solution. There are many impurities which are dissolved in it, including gaseous. Yes, so being a water solution, it is having many impurities which are dissolved in it and including gaseous. So what happens when you supply heat to that water? What happens? The gaseous will be dissolved until you supply 100 degrees Celsius. After reaching 100 degrees Celsius, gases will not dissolve. They will not soluble. They are not soluble in water. So up to 100 degrees Celsius, gases are soluble. But after reaching 100 degrees Celsius, gases are not soluble in water. So when they are not soluble, as a result, what happens means these gases will form as a bubble. They will form as a bubble. Yes, the formation of bubbles takes place where? At the bottom of the vessel or else on the walls of the vessel. Yes, so when water is being boiled at 100 degrees Celsius, automatically what happens? The gases will not be soluble. So when the gases which are present in water are not soluble, what happens? They forms as a bubbles. From where they will forms that bubble? At bottom of the vessel, or else because we are supplying heat at the bottom now. So that's why at bottom bubbles are formed, or else on the walls of the vessel bubbles are formed. So that bubble is consisting of some saturated vapor. Some saturated vapor is present in that bubble. So it is having some saturated vapor. Okay. So when this saturated vapor is present in that bubble, it is equal to the atmospheric vapor, means the pressure will, it will be having some vapor, no? The surrounding we will be having some vapor. So when that saturated vapor is equal to the atmospheric vapor, automatically what happens? That bubble will come to the surface of the water. That bubbles will reach to the surface of the water. So after reaching to the surface of the water, what happens? They will collapse. So they will collapse and they will release that vapor into the air. They will collapse and they will release. That means they will blast, you know. So when there is a blast of the bubble, automatically the vapor which is present in that bubble, it will comes into the air. So when it is coming to the air, when it is collapsing, when that vapor, that bubbles are collapsed, what happens? The phase is being changed. That means here the phase of the liquid is going to change into the gas. Yes, so here boiling is nothing but we are changing liquid phase into the gas phase. When we are boiling a water, what happened here? That bubble was collapsed. So when it is collapsed, what happened? The phase of it is changed from liquid to gas at a constant temperature. What is that constant temperature? At 100 degrees Celsius, this process, whole process has happened. So when it is happened at a constant temperature, when we have placed at 100 degree Celsius. So what is the definition of the boiling? Means we can say that, I will write the definition. Boiling is a process in which the liquid phase changes to boiling is a process in which the liquid phase changes to gaseous phase at a constant temperature at a given pressure. Is called boiling. Yes, if you want to write definition of boiling, means boiling is a process in which the liquid phase changes to gaseous phase at a constant temperature at a given pressure is called as a boiling. So what happened here? That bubble having some vapor, it is changed into the gas. When it is released into the air, it is changed into the gas at a constant temperature. When we are going to supply more temperature, so when we are increasing here temperature, according to that pressure, it is going to be released into the air. Yes. So though we are supplying more amount of heat, but it is going to take at 100 degrees Celsius only. So what happened to remaining heat energy? So let's see about remaining heat energy. So though we are supplying more amount of heat energy, it is going to take up to only 100 degrees Celsius. So what happens to remaining heat energy? What happens to remaining heat energy means the amount of heat energy required to change 1 gram of liquid into the gaseous at a constant temperature is called as a latent heat of vaporization. So what we call that heat? That heat energy required to change 1 gram of liquid into gaseous at constant temperature is called as a latent heat of vaporization. Okay, and latent heat of vaporization is denoted by capital L. Yes. So the amount of heat energy required to convert 1 gram of liquid into the gaseous at constant temperature is called as a latent heat of vaporization. So L is equal to, we can say heat as a Q. Yes, heat is represented by Q and the mass of the liquid is denoted by M. The mass of the liquid is denoted by M. So we have taken here some liquid and we are going to apply some heat. So when you are going to apply some heat energy, it is denoted by Q and it is having some liquid mass, no, that mass is denoted by M. So what is the formula of latent heat of vaporization? Means it is L equal to Q by M, heat by mass. Okay. So what are its units? So let's see its CGS unit. So heat CGS unit is calorie. Yes, calorie by mass. Mass in CGS is grams. It is grams. And what is the SI unit of heat? Already we know. SI unit of heat, it is the CGS. Now we are going to write SI units. So heat SI unit is joule. And mass is SI unit is kg. So calorie by gram is expressed in CGS unit. In CGS unit we have expressed it. And joule by kg, it is expressed in SI units. Yes. So the SI unit of latent heat of vaporization is joules per kg. Its units we can say. And here the latent heat of vaporization CGS unit is calorie by gram. Are the process of evaporation and boiling are same? No, they both are not same because evaporation takes place at any temperature and boiling takes place at constant temperature. Okay, so we have seen about boiling and what is latent heat of vaporization and what is the value of latent heat of vaporization. The value of latent heat of vaporization is 540 calories per grams. Yes, when we are going to take 1 gram of water at 100 degrees Celsius or 1 atmospheric pressure, the value of latent heat of vaporization is 540 calories per grams. So next topic is about melting. Let's see about melting. So next, melting. So melting. To know about melting, let's do an activity. So in 11th activity, first you have to take a beaker. In that beaker, take some ice cubes. Yes, small ice cubes you have to take. And insert a thermometer.
Hi Andy, అందరికీ నమస్తే.
And insert a thermometer. So first we have taken a beaker. In that beaker we have placed some ice cubes. Next you have to insert a thermometer. So after that you have to heat them. To heat that, what you have to do? You have to keep it on the burner. So when you keep it on the burner, just you supply some heat energy to the beaker. So when you heat that beaker, what happens? That ice start to melt. Yes, yes. So when it is going to melt, after supplying heat energy, you just note down the readings which are coming in the thermometer for every minute. Yes, so note down the reading, what is coming in that thermometer for every minute. You have to note down. So what changes you observe? You can observe after supplying heat energy to the ice cubes in the beaker, they are going to melt completely into the water. That means when at first it is going to be in the state of solid. So when you are going to supply heat energy, it is going to change into the phase of liquid with the help of the heat energy. Yes, yes. So when you are going to supply heat energy to that vessel, what happens? Will it have constant temperature or it is going to change its temperature? The temperature will be increased or decreased? It is not going to increase its temperature or decrease its temperature. It is going to have a constant temperature. So why like so it is going to have a constant temperature? Let's see. So why it is going to have constant temperature means, when you are going to supply heat to that beaker, that ice cubes is going to have some internal energy. In previous video already I have explained about internal energy. Yes, so if you want to know more about internal energy, you can check out that videos. So when you are going to supply heat energy to that ice cubes, the ice cubes which is having internal energy, that internal energy will be increased. So when it is going to increase its internal energy, what happen means, the bonds which is having in this ice cubes, it will be weakened. When the bonds of ice cubes are going to be weakened, they will break its bonds. That internal energy is going to be weaken the bond. So when that bonds of these ice cubes is going to be weakened, it breaks the bonds of the ice cubes. Yes, so when it is going to break the bonds of the molecules of the ice cubes, what happens? It is going to be converted into the liquid water. Yes, so when it is going to be converted into the liquid by maintaining constant temperature only. Yes, so when you are going to supply heat energy, it doesn't change its temperature. It is going to have constant temperature only. So when you are going to supply that heat energy, what happens? The internal energy which is present in ice cubes, it weakens its bonds. So by weakening that bonds, it breaks its bonds of the molecules of the ice cubes. That process is going to happen. So this is called as a melting. So the solid state of these ice cubes will be converted into the liquid state. That means the ice cubes are going to be melted by having the constant temperature. Yes, so if you want to write it in a definition form, I will write it now. Yes, this internal energy. Let me write the definition. Yes. The process of which the solid phase changes to liquid phase at a constant temperature is called melting. And that temperature is called as a melting point. Yes. So what is the definition of melting? The process of which the solid phase changes into liquid phase at a constant temperature is called as a melting. And the constant temperature is called as a melting point. So at what temperature it is going to be converted? Means it is going to be converted at, if first suppose at beginning this ice cube is at below 0 degree Celsius or else 0 degree Celsius. In kelvins we can say it as a 273 kelvins. Yes, so if ice cubes before heating, if it is at a below 0 degree Celsius, it continuously converts by supplying heat. It converts into, it comes to the stage of 0 degree Celsius. At beginning, if it is having temperature of 0 degree Celsius. Yes, so by supplying heat, what happens? It comes to 0 degree Celsius. Yes, okay. In Kelvin, if you want to express, means it is 273 kelvins. Yes, 0 degree Celsius is nothing but 273 kelvins. So by giving heat energy, it is going to have continuously, you are supplying heat, means it is going to have that 0 degree Celsius only, completely melted into liquid means. Yes, it is not going to change its temperature. At constant temperature only, at 0 degree Celsius only, it is going to be melted. Yes, okay. So that constant temperature, it is nothing but it is a melting point. Okay. So though we are supplying continuously heat energy, so what amount of heat energy is required to convert 1 gram of solid into the liquid? So what amount of heat is required? Let's see. So the heat energy required to convert 1 gram of solid into liquid at a constant temperature is called as a latent heat of fusion. Yes, so the heat required to change 1 gram of solid into liquid at constant temperature is called as a latent heat of fusion. Latent heat of fusion is also represented by capital L only. Yes, we have represented latent heat of vaporization with capital L, and here the latent heat of fusion, it is nothing but the amount of heat required to convert 1 gram of solid into liquid at constant temperature is called as a latent heat of fusion. So latent heat of fusion also, for that also heat is required, and it is also having mass. So the formula of the latent heat of fusion is also L equal to Q by M. So already we know units. Q SI unit, heat SI unit is joule by M, mass SI unit is kg. It is SI units. And if you want to write CGS units, it is heat SI completed CGS. Heat CGS unit is calorie, and mass CGS unit is grams. So the SI unit of latent heat of fusion is joule per kg, and CGS unit of latent heat of fusion is calorie by grams. So the value of latent heat of fusion of ice, yes, the value of latent heat of fusion is 80 calories by gram. Yes, the latent heat of fusion value is 80 calorie per gram, and the latent heat of vaporization value is 540 calories per gram. But here the latent heat of fusion value is 80 calories per gram. Yes. So by this experiment we have seen how to change the solid phase into the liquid phase. So what happens when it is going to change it? What happens? Its internal energy will be increased. So when it increases in its internal energy, it is going to have constant temperature only. At constant temperature, these ice cubes will be melted into the water completely. Yes, so that stage we can say it as a melting. At that constant temperature we can say it as a melting point, and the amount of heat energy required to convert 1 gram of solid into liquid is called as latent heat of fusion. The value of latent heat of fusion is 80 calories per gram, and latent heat of fusion L equal to Q by M, SI units joule by kg, and CGS unit is calorie by grams. This is all about melting. Yes, okay. So next we are going to see about freezing. This is the last topic of the heat chapter. So let's see about freezing. So freezing. We know that coconut oil or else ghee, they are in the liquid state. But in winter season, coconut oil and ghee, they will converted into solid state. Why? Though they are in liquid state, but coming to the winter season, they are being converted into solid state. So what's happening? Okay. So let's see about it. And next, if you take water, when you keep that water in refrigerator, it will be converted into solid form. So water is in the liquid state, but when you are going to place that water into the refrigerator, it is going to be changed into solid. So why like so? What's happening there? What happening? Let's see. So if you take a water, if you place that in refrigerator, what happens? At initial, before placing that water in refrigerator, at initial it is going to have more temperature, but after changing its state into solid, that is ice, it is going to have less temperature. At initial state it is going to have more temperature, and after converting its state into the solid, it is going to have less temperature. So why like so? Because when it is going to change from liquid state to solid state, it is going to lose some energy. So what type of energy it is going to lose means it is going to decrease its internal energy. Yes, it is going to decrease its internal energy. So when it decreases its internal energy, so what happened means it is going to converted from liquid state to solid state. So that is the reason when it is going to placed in refrigerator, it is going to be converted into the solid form. Yes, so the conversion of liquid state into the solid state is called as a freezing. It is nothing but freezing. So let's see the definition of freezing. The process in which the substance in liquid phase changes to solid phase by losing some of its energy is called freezing. So freezing is nothing but the process in which the substance in liquid, that means water is in the liquid state. So it is going to be changed into solid state. That means it is going to change in ice by losing some of its energy, by losing its internal energy. So when its internal energy decreases, it is going to change from liquid state to solid state. So that is called as a freezing. So at what temperature it going to take place means it is going to take place at 0 degree Celsius or at 1 atmospheric pressure. So 1 atmospheric pressure. So it is going to take place at 0 degree Celsius or at 1 atmospheric pressure. Okay. So what is freezing? Now we know. So the volumes of ice and water. When this ice is going to be conducted with same amount of water, no, then the volume of water and the ice are same or not. So to know that, let's do an activity, the last activity in this chapter, that is 12th activity. So to do this activity, just what we have to do means we have to take a water bottle. So after taking that water bottle, just keep the lid tightly, yes, tightly, and fill that water bottle full of water without having any gap in it. Okay, so we are going to fill that water bottle full of water without having any gap in it. So after filling it like so, what you have to do means you just take that bottle and keep it in refrigerator. Yes, so after filling it with water, you just keep that bottle into refrigerator. Yes, so just after 4-5 hours, you have to keep in deep refrigerator. Yes, deep freezer you have to keep. So when you are keeping this bottle in deep freezer, after 4-5 hours, you just take it out. So what you observe, that glass water bottle will be broken. Why it is broken? Because what we have did here, we have taken a glass water bottle, we have filled it full of water without having any gaps. So the volume of water which is present in that bottle is equal to the volume of water. Okay? Okay. So the volume of water which is present in that bottle is equal to the volume of bottle. Okay. So next, so after 4-5 hours, we have taken that bottle out from the deep freezer. So when you take water bottle out from the deep freezer, what you observe? You observe that the bottle is broken. So why like so? Because when it is in the liquid state, the water is in the same volume of water bottle. But when it is going to converted into solid state, the volume of the ice is greater than the volume of liquid in the bottle. So that's why the volume, when it is increased, the bottle is going to be broken. Yes, so that means the water is having less volume after becoming as a solid, as ice, it is going to have more volume. So that's why that bottle is broken. Okay. So some of you may raise a doubt that though the volume of the ice is more, but why it flows on the water? Yes, it flows on the water. Already we know density is equal to mass by volume. So that means for the density, the volume is inversely proportional. Yes. So when these ice cubes are having more volume, density is less. Here, though the density is less, it's though the volume is less, its density is more. But here for ice cubes, it is having more volume, so its density will be less. So the ice cubes are having more volume when compared to the water. So what happens? This ice cubes is having more volume, so it is having less density. So that's why ice cubes flows on the water. Okay, yes. So this is all about this 12th activity. It is nothing but we have taken a glass water bottle. We have filled it full of water. After that we have kept in deep freezer. So after 4 or 5 hours we have taken out. So when we see that bottle, it is broken. Why it is broken means the volume of the ice is greater than the volume of the liquid. Yes, so that's why it is broken. So when it is having more volume, it is having less density. If it is having less volume, it is going to have more density. Yes. So in this video we have completed 3 concepts about boiling, melting and freezing. So in this last video, this is the last video of chapter heat. So by this video we have completed heat chapter. So next chapter we are going to discuss. So if you are having any doubts, you can comment me down, and if you like the video, just do subscribe, like, share. Thank you.